Hey everyone, it's Mrs. Fallon again. I am going to talk to you through how to do transformations of logarithmic functions this time. So I'm going to use the same chart that I did on the last video, which was about exponentials. So we talked about horizontal translations, which is shifting left and right, vertical translations, which is shifting up and down, your reflections, your horizontal stretches and shrinks, and your vertical stretches and shrinks. So I want to make sure you understand what it looks like on a log function. Okay, so horizontal shift left or right. So for a log function, what that would look like, is if I had like f of x equals, say, log of x plus 1, or if I did log of x minus 1. So this is like your h value again, and so what this means is this is going to shift it to the left. So again, kind of the opposite in the way you think it should go, and this is going to shift to the right. So again, that's your shift left and right. That's your horizontal translation. For your vertical translation, which means just up and down, we're going to do, let's say if I did log of x and I say I added 2, or if I did log of x and I subtracted 2. So this is your k value. So remember, with your k value, it follows the way you think it should follow. So this would move up, this would shift down. Remember, with log functions, your asymptote is it's the inverse of an exponential. So an exponential, your asymptote had to do with your k value, whereas in a log, it has to do with your h value. So this would be your asymptote, like this -1 or 1 here, if you were to graph that function. All right, just like with exponentials, we're going to talk about reflections over your x or y-axis. So there's two different kinds of reflections. The first one is if you have a negative out in front. And this is probably the more common of the ones you will see. Those will be like log of x. So that negative out in front. This causes you to have it flipped kind of about the x-axis. It's easier to kind of show that one once we get into graphing, but I'll get to that in a minute. And then the other reflection is where the negative is kind of attached to the x. And that's a reflection over the y, or in the y-axis. So again, two different kinds of reflections, where the negative is out in front or the negative is kind of attached to that x. All right, let's talk about horizontal stretches and shrinks. And just like with exponentials, it has to do with the number that's kind of being attached, or being multiplied, or in this case divided by the x. So if you're going to be dealing with logs, so if I had log of 4x, or if I had log of 1/3 x. So if I did this one, this would be a horizontal. Again, it kind of goes the opposite direction. So this one is a shrink, and it's by a factor of 1/4. And this would be a stretch by a factor of 3. So again, it's kind of being multiplied here, so it's the opposite. So you'd think this would be a stretch because it's a bigger number, but it's actually a shrink, and it does the reciprocal, so the opposite here, and it does like a 1/4. And this one is a stretch, and it's by a factor of 3. The vertical stretch or shrink kind of follows similar plan. So this one, if I did like 3 log of x versus 2/3 log of x. So again, it's your initial value. It's that number that's out in front, your a value. So what this does is causes your graph to shift, or to stretch, I should say, vertically. So if there's a bigger number, a number bigger than 1, this is going to be a stretch. Oops, sorry. This is going to be a stretch, and it's going to be a factor of 3. And this is going to be a shrink, and this is going to be a factor of, in this case, 2/3. All right, let's do some examples together so that you guys can get a feel for what I mean by this. All right, so I'm just going to give you 3. We're just going to talk about transformations, and that's it. So let's start with this 3. This is kind of what we just left off with. This is going to be our vertical stretch or shrink. So in this case, it's going to be a stretch. So vertical stretch. And you can put by a factor of 3, or you don't really have to because it's kind of assumed in there. This is going to be our shift left or right. So in this case, it's going to go right 1. And remember, this is your asymptote, so don't forget about that when we actually get to graphing. And this plus 2 is going to cause my graph to shift up 2. So again, if you were kind of going to describe kind of the transformations of a log function, you just have to kind of talk about what each individual number does to my graph compared to its parent function. All right, this one we haven't talked about yet. This is when the base of the log is something like a fraction. So anything less than 1, greater than 0, but less than 1. This does the same thing as a reflection in the x-axis. So it does the same thing as if I had like a negative out in front of this log. And so it's just kind of worth noting. So this what actually means a reflection in the x-axis. This plus 4 here would shift my graph to the left 4. And don't forget that this is also your asymptote because it's your h value. All right, last but not least is your log function. I put a couple different things in here. So first, this negative, that's going to be a reflection. But remember, this time the reflection is going to be in the y-axis. So think this way. And then it's going to be this 2 causes my graph to have a horizontal shrink by a factor of 1/2. So again, what the negative does, what the 2 does to my overall log function. And natural log is graphed the same way as a log function, just it's using natural log instead. All right, let's go through some graphs of some log functions so I can show you exactly what you need to be able to do.